Okay, so today we're going to look at quartiles, percentages, and interpolation. I've got a few kind of talky bits to go through, and then we will do a couple of examples of how to use interpolation for group data and continuous data. Okay, so quartiles and percentages. Okay, hopefully we all know what we're talking about with quartiles. So it's a measure of location. And obviously we use median to find the middle point, and then we use quartiles to find the lower quarter and the upper quarter, and then percentiles, obviously we can find different percentage points across a set of data. Okay, if our data is discrete, so it's in a list, you have separate pieces of data, then we use slightly different methods to when we look at continuous data or kind of data in a grouped frequency table. If we have discrete data, we have a list. To find the lower quartile, we divide n, by which I just mean the number of pieces of data in the set. So we divide n by 4. So if you have a list of 12 numbers, we would divide 12 by 4, and that would get us the lower quartile. If that number is an integer, so for 12 divided by 4 is a whole number, it would be 3, then the lower quartile is halfway between this data point and the one above. Okay, so it would be, so again, if we use 12, it would be the 3.5 data point. So it would be between the third and the fourth. Okay, if it's not an integer, then we round that up. So say it was, trying to think of something that I can divide by 4 in my head. Say it was 13, and you divide 13 by 4, you get 3.25. Unless I'm very much mistaken, but 3.25, you get a non-integer value. We would round that up to the next data point. So even though it's 3.25, and normally we would round that down to 3, we always round up, so it goes up to the next data point. Okay? For the upper quartile, we do the same thing, but with 3/4. So we find 3/4 of n, and again, if that's an integer, the upper quartile would be halfway between that data point and the one above it. And if it was a non-integer, if it was a decimal, then you would round it up and use that data point. Okay, so hopefully that makes sense. And we can look at continuous data or data in a grouped frequency table. So we use interpolation, which I'm never sure I'm saying that word right, but here we go. We use interpolation to estimate the median, quartiles, and percentiles. When you use interpolation, you are assuming that the data values are evenly distributed within each class, which is why it's an estimate, because we are assuming something. That is not necessarily true. If you have, a frequency of 5 between 1 and 10, we are assuming that those 5 pieces of data are evenly distributed between the interval 1 and 10. But we don't know that. They could all be 1 for all we know. So we are assuming something, which means any information we get about measures of location, they're all estimates when we're looking at group frequency tables, because we don't actually know the exact pieces of data that have gone into that frequency table. It's slightly different for finding your quartiles and your median. There's no rounding or going in between numbers for continuous data. For the lower quartile or Q1, as I will refer to it as we go through the examples, to find the lower quartile, you again take the number, so take the total frequency and divide it by 4. If that's a decimal, it stays a decimal. If that is an integer, it stays an integer. There's no rounding up or choosing different values. It's straight up, divided by 4, that's your data value. For Q2 or the median, we divide it by 2 and we take that data value, and same thing, there's no rounding, whatever that number is, we choose that data value. And then Q3 would be your upper quartile. So you're finding 3/4 of n, so the 3n over 4th data value. I hope that makes sense. And we will have a look at that in action on the next slide. And I'm going to give you an example of how to use interpolation, using a bit of proportion to be able to work it out. So here's our question. We have the length of time to the nearest minute spent on the internet each evening by a group of students is shown in the table. First of all, what an inaccurate table. I know for a fact that most students would spend way more than 39 minutes on the internet every evening. But anyway, so we have our classes, our intervals, we have our frequency, and we want to find an estimate for the upper quartile. Now, first of all, your total frequency is 70. When you add all of those frequencies up together, you get 70. So you've asked 70 students all together. To find an estimate for the upper quartile, we first need to know what value we are interested in. So for the upper quartile, we need to find 3/4 of 70. 73 times 70 and divide it by 4, which means we are interested in the 52.5 value. So we are looking for that data point within our frequencies. So to use interpolation, we need to think of two things kind of at once. So we need to think of the class that we're interested in, and the frequencies that we have within that class. Okay, so if we're looking for the 52.5 the 52.5 value, that is going to be somewhere in this interval. Okay, because we've got the first two people are in here. If we do a bit of cumulative frequency in our head, you would get up to 27 by adding on the next frequency, and then we would get up to 57 by adding on the next one. So think of, it might help to maybe do the cumulative frequency underneath. So that'd be 27, that would be 57, and then that would be 70. Okay, so cumulative frequency will definitely help be able to identify where the 52.5 value would actually be. So it would be in this interval. So I do find the diagrams help. So that at the top, I'm going to put the information about the interval that I need, and on the bottom, I'm going to put the information about the frequency or the data points that I've got. So 3 points. So you have your end points, and then the point where the upper quartile is. So this is our Q3. This is what we're trying to find, our upper quartile. That is somewhere between. Now, watch out for this, because it catches me out a lot, if I'm honest. Remember, you have to look at the class boundaries. So because there's a gap between 33 and 34, we need to remember that our class boundaries go from 33.5 to 36.5 to get rid of those gaps between the classes. Okay, so our lower boundary would be 33.5, like that, and our upper boundary would be 36.5. And then our frequencies, or our data points that we're interested in, are 27, because that is the cumulative frequency at the beginning of our interval, and 57, because that is the cumulative frequency at the end of our interval. And we are interested in the 52.5 value. Now we can use a bit of proportion to work this out. I'm going to put a line here just because I like the use of, it's like a number line, isn't it? There we go. So we're going to use a little bit of proportion. So to find the upper quartile is a fraction of the way through that interval. We would find it by subtracting whatever the Q3 value is, finding the difference between that and the beginning of the interval, and dividing it by the size of the interval altogether. So we would do Q3, whatever that is, minus the lower boundary, because that is how far Q3 is into, yeah? So whatever Q3 is, we would find the difference between that position and the lower class boundary to find out how far into that interval we've actually gone. And we would divide it by the interval size, okay, to change it into a fraction. To say we are, 2/5 of the way through this interval. We would find the difference between the beginning of the interval and where we actually are, what data point we're interested in, and divide it by the total class, the total size of the interval, which in this case would be whatever 36.5 minus 33.5 is. Yeah? So it's the difference between the upper boundary and the lower boundary. And then we can put that equal to the fraction for the frequency, which is what we can actually work out, and that's going to help us find out what Q3 is. So our 52.5 is also a fraction of the way through the frequencies. So that is a fraction of the way fraction of the way between 27 and 57. And we need to work out what fraction that actually is. So again, we would take the 52.5 and we'd find the difference between that and the lower boundary. And we would divide it by the, what am I trying to say? The size of the interval, which in this case is 57 minus 27. Okay? So this is telling us what fraction of the way through the data 52.5 actually is. And then we can use that and put it equal to a similar fraction, and then use that to be able to work out what Q3 actually is. So let's work some bits out. We get Q3 minus 33.5 over 3 is equal to 25.5 over 30. So our data point, our 52.5, is 25.5 over 30 is 25.5 30ths of the way through the interval. Okay, I'm going to change it to a decimal just to make the calculation a little bit more straightforward. I'm possibly going to run out of room, but let's just keep going. So divided by 3 is equal to 25.5 over 30 is 0.85 as a decimal. And then I'm just going to rearrange until I get Q3 on its own. So just do a little bit of algebra. So I can have Q3 minus 33.5 is equal to 2.55. Then I'm going to add the 33.5 over. Gives me 36. Have I done something wrong? No, 36.05. Yeah, 36.05. And that is an estimate for the upper quartile of that data, 36.05. Okay, so it is really at the upper end of this interval so far that it's actually in the gap between 36 and 37. Okay, I hope that makes sense. I'll do a similar example for the next for part B, except we're using percentiles instead of quartiles. So find an estimate for the 10th percentile. So again, we've got 70, a total frequency of 70. If we do 70 divided by 10, then we are interested in the 7th data point. We need to find what the 7th data point, or find an estimate for the 7th data. Oh no, that's really annoying. I'm not starting again from the beginning. Okay, so we are looking for what the 7th data point is again. So again, think of your cumulative frequency. We've got 2, 27, 57, 70. Our 7th data point is going to be in that second interval. It's going to be somewhere between 32 and 33. Use the diagram again. I like the diagram. It helps me make sense of it in my head. So we've got 3 points. we've got the ends of our interval, and we've got where the actual percentile is. So the end of our interval, again, remembering your class boundaries, would be 31.5 and 33.5. We're interested in the 10th percentile. Oh, what did I do there? P10. Okay, and then again, look at the frequencies within that interval. And it starts at 2, it ends at 27, and we're interested in the 7th data point. I'm going to put my line in just because I like it, makes me feel happy. Then I am going to, again, use a bit of proportion to work that out. So our P10, we need to know what fraction of the way that is through the interval. So we would do P10 minus the lower boundary and divide it by the size of the interval, which we would find by doing 33.5 minus 31.5. Yeah, so just to make that really clear, you don't necessarily have to write it out as a subtraction. You know the size. You should be able to work out the size of that interval, but the difference between 31.5 and 33.5. It is 2. So we could just write 2 if you didn't want to go, and write everything in every time. You can work a lot of it out in your head. The size, that is just the size of the boundary, which in this case is 2. And same kind of goes for the frequency side of our equation. You want to know what percentage of the way between 2 and 27 the number 7 is. So again, you can do that by just saying, okay, well, the difference between 2 and 7 is 5, and we're dividing it by the difference between 2 and 27, which is 25. You can do all that in your head, but for the purpose of this example, I am going to write it all out in full. So we're doing 7 minus 2 to work out how far into the interval 7 is, and then we're working out the size, the number of data points we have within that interval, so 27 minus 2. Work out the bits that you can, so P10 minus 31.5 over 2 is equal to 5 over 25, or 0.2. I'm not going to put it on a new line or I'm going to run out of space. I'm going to multiply the 2 across, so I get P10 minus 31.5 is equal to 0.2 times by 2 is 0.4. And then I'm going to add the 31.5 across, so I get 31.9. So that is your estimated value for the 10th percentile would be 31.9. And again, it's actually not even, it's still in the gap between those two intervals because it's not very far into that interval at all. I hope that makes sense. And I hope it helps with your work on interpolation, quartiles, quartiles and percentiles with grouped frequency in your A-level stats. Thanks for listening, and I hope it helps.